Miss Weaver, and this is actually an example that there's a video for already, but it's rather long, and I'm not sure why it's quite as long as it is. So I wanted to see if I could do it a bit quicker. So with this example, we are trying to run a hypothesis test. We have data, and we're gonna be running a hypothesis test for the mean salary of our example here. So we're told that a college career counselor claims the mean annual salary for home care physical therapists is $75,000. So I'm actually going to go ahead that is my claim. So mean, so I'm going to use mu. I didn't make my lines long enough, did I? So mu equals 75,000. The annual salary in dollars for a random sample of 12 home care physical therapists are listed in the table below. This is also in our StatCrunch group. If you want to go and find it, you can go along and do this. We're wanting to know at the 2.5% level of significance, is there enough evidence to disprove the claim that the mean salary for home care physical therapists is in fact $75,000? So remember, our claim and our counterclaim should be complements of one another. So if we have equal, then our counterclaim would be not equal. In this case, anytime we have equality, so whether it is less than or equal to, greater than or equal to, or exactly equal to any of those three, if our claim is any of those three, then it is going to be the null hypothesis. And I'm going to go ahead and mark it as claim. And then my counterclaim is going to be the alternative. If my claim does not include equality, then it would be, the claim would be the alternative. So it's not always that the claim is a null. It's that if it has equality, our null hypothesis also has to have equality. All right, so because this is a not equal to alternative hypothesis, that's going to be a two-tailed test. So we're going to get that not equal to symbol, and we can point an arrow in both directions. That's always going to be based off of the alternative hypothesis. Our significance level, so that was given to us at the 2.5% level of significance. So I always like to put that as a decimal because StatCrunch is going to give me the number that I need to compare to this significance level is going to be a decimal. It's going to be a proportion between 0 and 1. All right, and then our rejection criteria is based off of what our significance level is. So we are always going to be trying to reject or fail to reject the null. So our decision that we're making is always based on the null hypothesis. To reject the null hypothesis if our p-value is less than or equal to 0.025. So from here, we're going to go to StatCrunch, and I'll go ahead up here in the margin. We're going to go, once we're in StatCrunch, we're going to go stat. Since we're dealing with means, we're going to go to the t-stats. And of course, we're only dealing with one sample. And in this specific case, we actually have data. So I'll select that first option with data. I don't have a picture of the screen that you'll fill in. Unfortunately, I didn't print that part off. But when you're doing the with data, you'll just select the column that the data is in. And then you'll make sure that your null and alternative hypotheses match up. Everything else can be left alone, and you can click compute. So I do have the outcome. So our outcome when we run this one sample hypothesis test for this T, we can double check that our hypotheses match up. So yes, the mean is equal to 75,000. Alternative hypothesis is the mean is not equal to 7,500 or 75,000. Our variable, so that was just the column title in StatCrunch. The sample mean, if I needed it, that would be the X bar. The standard error is not going to be a number that we need to worry about, but if you're curious, it would be the sample standard deviation divided by the square root of n. You are not going to need that number or be asked to identify that number or that formula, but there you go. The degrees of freedom, remember that is just one less than the sample size. So n minus 1, we had 12 in our sample, so our degrees of freedom was 11. And then once again, it's the last two numbers that we really care about, and even more so the very last number. But in Pearson, you'll need to be able to put both of these in. So your t-stat, in Pearson, you're going to have a t equal and then a box to put your number in. And then it's going to have p-value and a box to put that number in. So I'm going to go ahead and write down both of these numbers. I'm just going to round to 3 decimal places for that t-stat. So I'm going to say that t equals, so it would be, if we were doing proportions, we would actually have a z instead of a t. But since we're dealing with means and the student t distribution, our test statistic will be this t. And actually I'm going to go ahead and write out the entire number. 2.4647534. It's a nice thing to do, especially if you're doing, I'll have this for, paper like this for your scratch work on your test. If you have that whole number written out from StatCrunch, it might help me figure out if it ends up being wrong. Was it just because you rounded wrong, or you gave 3 decimal places when it asked for 2, or whatever else might have happened. So my t, and then my p-value. So StatCrunch is telling me that the p-value is 0.0314. Remember, our p-value is the probability of getting something as extreme or more extreme than this number, or than the sample mean that we had, which was more than 75,000. However, at this significance level that we're told to use, it is not extreme enough. So back when we were just using 5% as our comparison, we would have said that this was unusual. But remember, we can only reject the null hypothesis if our p-value is less than or equal to 0.025. Well, if I put in my p-value instead of the word p-value, and then I put in my significance level, when I try to compare those two numbers, I do not have less than, I have greater than. So that's telling me that I'm going to fail to reject the null hypothesis. When we write our conclusion, the first thing we want to do is say whether or not we found evidence, and our evidence, we only have evidence if we were able to reject the null hypothesis. So since we said that we failed to reject, let's say that there is not and that is based on my decision exactly and only. There is not sufficient evidence at the, and then I want to use my significance level. So there is not sufficient evidence at the alpha equals 0.025 level of, oops, significance. I'm going to abbreviate because I think I'm going to run out of room. So again, this is just directly based on what was used to make our decision, which would have been given in the problem. 2, and are we trying to support the claim, or are we trying to contradict or disprove the claim? Well, if the null hypothesis is the claim, we want to try and disprove. If the alternative was the claim, then we would be trying to support. So we do not have enough evidence at the 0.025 level of significance to disprove and that is because the claim was the was the null hypothesis. The claim that, and I'm definitely running out of space, the mean salary for home care physical therapist, I'm going to abbreviate therapist, is $75,000. So we ended up with a sample mean that was higher, but it wasn't significantly different from the mean that we were told. So what if just a few things changed? So the Dean of Health Sciences at a community college wants to recruit students to her program and makes a poster that claims the mean annual salary for home care physical therapists is more than $75,000. So our claim has now changed. The same sample, so we're still using this data, and significance level are used. So our 2.5% level of significance, that's not changing. What does change though? So my claim, right, that changed from equal to greater than, which means my counterclaim would change to less than or equal to. Well, if the equality changes from being included with our claim to being included with our counterclaim, then my null hypothesis, that's actually going to change to less than or equal to 75,000. And then the alternative will be that we are greater than 75,000. Of course, I'm going to mark that one as my claim. The alpha, the significance level, stays the same, which means my rejection criteria. So we're going to reject the null hypothesis if our p-value is less than or equal to 0.025. That doesn't change because our significance level didn't change. Oh, can't see what I'm writing, can you? There we go. Our test statistic. Well, when I go in, and of course I'm still using the data, so t-stats, one sample with data. The only thing I need to do differently is, and I can't actually change in StatCrunch. The null hypothesis in StatCrunch will always have to have the equal sign. But I will change my alternative hypothesis to be greater than instead of not equal to. So what numbers change and which ones do not? So my sample mean didn't change. My standard error didn't change. My degrees of freedom didn't change. Let me see if we can see both of them at the same time. So there we go. So all of these are the same. Even the test statistic, right? That's the exact same value, but the p-value is different. All the rest of them are the same. So as far as which aspects stay the same, my t equal to 2.464 dot dot dot. Oh, sorry, that one did not change. And this is the one pen that doesn't erase. My test statistic is still the same, but my p-value changed to 0.0157. And so now, as far as our decision is concerned, we put our p-value, 0.0157. We compare that to our significance level, 0.025. Well, this time it is less than. And so our rejection criteria, we can reject the null if the p-value is less than or equal to 0.025. It's less than, so we're going to reject the null hypothesis, which means we can support the dean's claim. So if we were going to write out our entire sentence, then we would say that there is sufficient evidence, because we were able to reject the null hypothesis at the 2.5% level of significance, to support the claim that the mean annual salary for home care physical therapists is more than $75,000. I'm not going to write that out just for time's sake, but hopefully this video ends up being a little bit shorter than the one that was previously posted. Let me know if you have questions.